So currently our add code does nothing other than check to make sure it was out of, then other than making sure then our it was in bounds. If it was out of bounds, right, then it tells us it was out of bounds and questions our competence, right? So now let's actually make it do something. So we would really like to store this item at this index, so let's go ahead and do that, right? And that's simply as easy as saying the data at index should be that item, right? And now that we've added that item, we can go ahead and just increment the size of the array, right? We've added something to the array, we should increment it. And that's as easy as it is, right? No, totally not. But we should really have some way to test this out to make sure it's working. So let's build a toString method, right? We need to know, doing this mentally, it's terrible. So let's go ahead and make a toString method. So public string, toString. This is a method we're overriding from what class? The object class, because everything has a toString method. The default behavior of the toString method, if you remember, is that it will print out a memory location. So let's do something a bit more useful. We're going to start by, well, let's try build an array. So just piecemeal, or an array output. Array output, right? The output for the array list, if I recall, it looks something like, right, it's like, with like an item here, and then another item here, right, and another item here, and the items are separated by spaces, item, and then you had this closing thing, then you had the closing curly brace, and that was it, right? So we've got this output over here. We'll just go ahead, and we're going to keep it simple. We're just going to put spaces in between stuff. No, actually, let's keep it real. So output like that. We'll add the items to it. We'll open it up. We'll add each of the items separated by commas, not by spaces, and then we'll return the output when we're done. So for each item in the data, well, actually, we're going to see why we can't just use this here. Yeah, why not? Let's shoot ourselves in the foot a few times first. Okay, for item in the data, we're going to go ahead and take that item dot toString, right? Output is equal to item. So we're going to concatenate that, right? Is the idea. We're going to convert the item to a string. We're going to concatenate that, and we're going to add on a comma to the end and a space. And then we're done. When we're done, right, we're going to add a closing bracket, right? Open a bracket, go through each item, get each item, and separate it with a comma and a space, right? So I'm going to go ahead and do, now part of the issue with testing this is both our list code and our toString code and our list add code don't do what we necessarily think they should do. So I'm going to just use up my, so I'm going to be clever about it. I'm going to add 0 to index 0 list add 1 to index 1. Because the issue is that right now with our add, it will add these things just fine, but it won't move anything out of the way yet, right? We didn't write code to handle that. List.add 3, 3, right? But this should be enough for us to test. List, right? Run this and start getting an error. Exception at thread main, null pointer exception in this, right? Well, null pointer exception in the print line. What's going on? Well, remember from my terrible drawing that I did, right? Here's our items, except we've got 0, 1, 2, 3 here in this example, right? We turned this into a string, put a comma and space after it, turn this into a string, put a comma space after it, turn this into a string, put a comma space after it, turn this into a string, put a comma and space after it. Then we get over to this. What is this? It's blank. It's a null, right? N-E-U, yeah, N-U-L-L. Null. Don't know why I thought there was an E in there for a second. That was kind of weird. Okay. Put a null there, and then we tried to do an item.toString, right? And we can't, nulls don't have any methods. So we tried to turn a null, this thing that represents nothingness, right? We tried to take this null and tried to turn it into a string, and it was like, no. Well, maybe if I didn't do a method call, what happens then? Right? Because then if it's an object, we'll automatically call the toString method. Oh, that's better. 0, 1, 2, 3, null, 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 comma space. Well, okay. First off, that comma space is coming at the end because we're doing every single item, right? Right. Every single item in there has a we say to put a comma and space at the end. So the way we wrote it, the last thing is always going to have a comma and space at the end. This is what we call the fence posting problem in 1068, which the issue is that you've got, essentially, we've got 10 items, and we want to put 9 things between them, right? 9 comma space combinations between them, right? You have more you have an unequal amount of fences and fence posts, right? So instead, what we need to do is just account for that. So So we'll just go ahead and do this the other way because we're going to need to do it this way. Anyway, for int I is equal to 1, I is less than the data dot length. And instead what we're going to do is that we're going to say output plus equals comma space, what? Plus the data, the item at I. And then we're going to change output to be plus the data I. Oh, not I, at index 0. So we're going to take the first item, just attach it. Then for every other item in the list, we'll plug a comma and space before it, and then we'll add the item to there. So if we run this now, watch what happens. Boom. Right? Because this runs 9 times, so we only get 9 connectors. Okay? We still got the nulls, but for right now, for diagnosing like our situation, for seeing how everything is going on as the add method works, I think it's okay to keep the nulls in. We'll remove them when we don't need them anymore. Okay? So this is going to be great for diagnosing our things. Now, the issue we're having right now is that as I add items, right, add index 2, add to index 1, 1, index 1, add 2, right? So as I'm adding items, I don't shift stuff over the way. I didn't implement that yet. So when I added 2 to index 1, it didn't shift 1 over. Instead, it just overwrote. And then when I added 3, well, it's like, oh, the size is 3. I'm just going to go ahead and just go right over here since there's 3 items over in it. So I'm going to go to index 3. But even though there were only 2 items in it, why did adding it over here think there were 3 items in it? Well, because we incremented the size every time we do an add operation. So we really need to get that shifting thing down, right? So how's that shifting thing going to work, right? We need to shift items over if we're inserting. Okay. So if I'm shifting over, so how's that going to work? So going back to this example, I've got a Z here. I want to move X and Q out of the way. Right? So how's that going to work? Well, what I can do is that I can, let's go ahead and, right? What I can do is that I can, oh, really? How weird. Okay. Sorry, 1 second. Technical difficulties there. What tools do I actually have here? Oh, there we go. Paintbrush, brush width. Let's make this much bigger. All right, so I want to insert Z. I need to move X and Q over. So I am going to go ahead and mute. So how can I do that? I want to insert Z. It needs to go to index 2. So that means that X is going to end up over here, and Q is going to end up over here. So the way I do that is actually I have to start from this end, because what I have to do is I have to take Q. So what I'm going to do is I'm going to copy Q and move it over into here. And then what I'm going to do is I'm going to copy X, and then I'm going to move it over here. X into there, and then I'll overwrite Z over here, right? So let's go ahead and go back, okay? Right, say I wanted to insert, instead I wanted to insert our Z over here. If I wanted to insert Z over here, we'd copy Q over to here, we'd copy X over to here, we'd copy B over to here, and then we'd put Z over here. We'd overwrite this, and then we'd overwrite what was there, right? And that would be safe to overwrite because B would be over here, and that would have been safe to, and that was safe to overwrite because X got written over here, and that was safe to do because Q got written over here, and that was safe to write to because this was null, right? We move this guy over here, we move this guy over here, move this guy over here. So when we insert an item, say I want to insert Z into index 1, what we do is that for every index, from index 1 to the end, is that we're going to take every guy, copy it over to the index to the right, and that's it. And then insert our item. All right? So we already got the insert our item part. So what we need to do is that if we need to, so what that means is that from index, the point that we're inserting our item, everything that's to the right of it, we need to copy that over. All right? And furthermore, we have to go like from this order. So let's go ahead and ask ourselves. So this is just a matter of properly writing our for loop. So we need to start at the end of the list. So what is the last index of the list? It is int I is equal to size minus 1, right? That's the last item in the list. And then when do we want to stop? Well, I is greater than index, right? We don't actually when we no longer at index. So I is greater or equal to index, right? We want to go from the last item in the list to here. And each of these items, we need to copy it over to the right. I minus minus. That makes sense, hopefully. Okay, for each item, starting from the last item, we're going to take each item, for each item, from the last item to this spot where we're inserting an item. What are we going to do? We're going to take each item and copy it over to the spot to the right of us. Okay? So let's go ahead and do that, and I'll split it up into lines first. So E item is equal to the item at I, so our the data at I. And now we need to copy that into the space to the right of us, to the index to the right of us. Okay? E item. We'll call this temp because we already used item. And then we're going to say the data, the space to the right of us, I plus 1 is equal to temp. Okay? And so now when we run our program, Oh ho! We inserted 0 at index 0. Then we inserted 1 at index 1. Then we inserted 2 at index 1, and that pushed 1 to the right. Then we inserted 3 at index 3. Let's try inserting that at index 0. Or sorry, whoops, that was adding 0 to index 3. Let's add 3 to index 1. Also, this gray thing isn't something that typed. That's just a hint that automatically comes up, which is useful for me remembering which of these numbers is the index and which of these is the item. So it's pushing things out of the way completely correctly, right? So we take for each of the items going down, each of the items in the list until we hit the index that we're inserting stuff at, right? We're going to include it though. We take that item and we store it in the spot to the right. The index to the right is the index that's 1 greater than us. That's why I put I plus 1 there. Okay, so some of the more astute people might have noticed that, oh, well, hold on a second. There's only 10 spots for capacity, right? There's only 10 spots that you have for capacity, right? Your array is only 10 big. What happens when you run out of space, right? Because there will be nothing to the right. You're going to get an array out of bounds exception, right? I'm going to just go ahead and show that by doing some copy pasting, right? I'm going to add a bunch of 3s to the beginning. Let's go ahead. Let's see where we are. Not at 10 yet, but I'm adding 3s to the beginning, right? Oh, we are at 10. Okay, now we add one more. Oh, array out of bounds exception, right? Because where at what line? This one, because there's nowhere to move it to the right. Our array got all filled up. Okay, so how do we deal with that now? Well, that will be the next video.